Hi, my name is Muhammad Lumba Hakim and I will explain about AC motor.
Hello, my name is Ahmad Izhar and I will explain about DC motor.
Assalamualaikum, my name is Muhammad Shazam Muskam and I would like to explain about the difference between AC motor and DC motor. Please enjoy the video.
There are two types of AC motor, which is synchronous motor and induction motor. So in synchronous motor, this motor have the rotor rotating at the same speed as the speed of rotation of the stator current. In other words, we can say this motor don't have slip with respect to the stator current. They are sometimes used not to drive the load, but instead act as synchronous condenser to improve the power factor of the local grid to which it is connected to. This kind of motors are used even in high precision positioning devices like modern robots. They can also act as stepper motor. For induction motor, the most widely used induction motor are very important for many industries due to their load bearing capacity and flexibility. This motor, unlike a synchronous motor, slip when compared to the stator current field. They are generally used for various types of pump, compressors, and acts as prime movers for many machineries. AC motors can find their usage in two forms based on their power supply. The single-phase motors are generally found their use in low power requirements or domestic appliance. The three-phase motor are generally found for high power requirements like power drive for compressors, hydraulic pumps, and many more. An AC induction motor has two basic electrical parts, a rotor and a stator. The stator is the stationary electrical component. It is built by putting together iron layers forming a group of individual electromagnets arranged in such a way that they form a hollow cylinder with one pole of each magnet facing forward. The center of the group magnetic poles are built by winding clockwise and anti-clockwise insulated copper wire. The coils are wound in such a way that when current flow in them, one coil is a north pole and its pair is a south pole. When AC power is connected to the coils, a directional flux is created depending of current's direction and winding direction of each coil. See in this animation how the magnet's polarity changes every half cycle of the AC power supply, creating an alternate magnetic field. The rotor is the rotating electrical component. It also consists of a group of electromagnets arranged around a cylinder, with the poles facing toward the standard poles. The rotor obviously is located inside the stator. As the magnetic field of the stator alternates due to the effect of the AC power supply, the induced magnetic field of the rotor will be attracted and will follow the rotation. It is a natural phenomenon which occurs when a conductor aluminum bars in the case of a rotor is moved through an existing magnetic field or when a magnetic field is moved past the conductor. In either case, the relative motion of the two causes electric current to flow in the rotor conductor. This is referred to as induced current flow. So for the application of AC motor, which is for single phase, it is used in residential applications such as washing machines, furnaces and air conditioners. Types of single phase motors include shaded pole, split phase and capacitor. So for shaded pole motor, it is used for computer cooling fan. For split phase motor, it is used for washing machine and small pumps. And for capacitor motor, for refrigerators and air conditioner. So for the three-phase, it is most common motors used in industrial settings because they are simple in structure, low maintenance and cost very little to operate, such as electric train engine, cooling fans used to cool large machines like alternators, chimneys at power plants, printing machines and rolling mills.
This is the simplest DC motor possible. It will look like this. The stator provides a constant magnetic field, and the armature, which is the rotating part, is a simple coil. The armature is connected to a DC power source through a pair of commutator rings. When the current flows through the coil, an electromagnetic force is induced on it according to the Lorentz law. So the coil will start to rotate. You will notice that as the coil rotates, the commutator rings connected with the power source of opposite polarity. As a result, on the left side of the coil, the electricity will always flow away, and on the right side, electricity will always flow towards. This ensures that the torque action is also in the same direction throughout the motion, so the coil will continue rotating. But if you observe the torque action on the coil closely, you will notice that when the coil is nearly perpendicular to the magnetic flux, the torque action near zero. As a result, there will be irregular motion of the rotor if you run such a DC motor. Here is the trick to overcome this problem. Add one more loop to the rotor with a separate commutator pair for it. In this arrangement, when the first loop is in the vertical position, the second loop will be connected to the power source, so the motor force is always present in the system. Moreover, the more such loop, the smoother will be the motor rotation. In a practical motor, the armature loops are fitted inside slot with highly permeable steel layers. This will enhance magnetic flux interaction. Springs-loaded commutator brushes help to maintain contact with the power source. A permanent magnet stator pole is used only for very small DC motors. Most often, an electromagnetic is used. The field coil of the electromagnetic is powered from the same DC source. The field coils can be connected to the rotor winding in two different ways: parallel or series. There are four basic types of DC motor. 1. Permanent magnet motor. 2. Series motors. 3. Shunt motors. 4. Compound motors. Okay, we will explain one by one of these. First, permanent magnet motors. The permanent magnet motor uses a magnet to supply field flux. Permanent magnet DC motor have excellent starting torque capability with good speed regulation. The disadvantage of permanent magnet DC motor is they are limited to the amount of load they can drive. These motors can be found on the low horsepower application. 2. Series motor. In a series DC motor, the field is connected in series with the armature. The field is wound with a few turns of large wire because it must carry the full armature current. A characteristic of series motor is the motor develops a large amount of starting torque. However, speed varies widely between no load and full load. Series motor cannot be used where a constant speed is required under varying loads. 3. Shunting motors. In a shunt motor, the field is connected in parallel shunt with armature winding. The shunt connected motor offers good speed regulation. The field winding can be separately excited or connected to the same source as the armature. 4. Compound motors. Compound motors have a field connected in series with the armature and separately excited shunt field. The series field provides better starting torque and the shunt field provides better speed regulation. Compound motors are further divided as 1. Short shunt. In this type, field winding is connected in parallel with only the armature winding. 2. Long shunt. Field winding is connected in parallel with the combination of series field. Okay, the application of DC motor. For the shunt motor, it is used in lattice, drills, boring mills, spinning, sharpers, and also weaving machine. Okay, for the series motor, it is used in electric, traction, branches, elevator, air compressor, vacuum cleanser, and also sewing machine. And lastly, for the compound motor, it is used in presses, shears, and reciprocating machine.
Okay, for my part, I will do the difference between AC motors and DC motors. While both AC and DC motors serve the same function of converting electrical energy into mechanical energy, they are powered, constructed, and controlled differently. The most basic difference is the power source. AC motor are power from alternating current, while DC motor are power from direct current such as battery, or AC to DC power converter. DC wood field motor are constructed with brushless and commutator, which add to the maintenance, limit the speed, and usually reduce the life expectancy of brushless DC motors. AC induction motor do not use brushes. They are very rugged and have long life expectancy. The final basic difference is speed control. The speed of the DC motor is controlled by varying the armature winding current, while the AC motor is controlled by varying the frequency, which are commonly done with an adjustment frequency drive control. And then all DC motor are single phase, but AC motor can be single phase or three phase. In DC motor, the armature rotate while the magnetic field doesn't rotate. In AC motor, the armature does not rotate and the magnetic field continuously rotate. And then DC electric motor have many moving parts that are expensive to replace. The DC electric motor repair is usually more expensive than using a new AC electric motor with an electronic controllers.